little unit circle connection. And I hope this works. Might be a little fun for you. We're going to read some of these. Actually, we're going to listen to some of these. So, sorry, I want to make sure I get this to work right. I think it's going to work.
Basically, sin 140 equals 0.64 means that the x and r, x divided by r or xr, equals 0.64 when simplified into decimal form. The cos 140 equals minus 0.77 means that the y and r, yr or y divided by r, when simplified into decimal form equals minus 0.77.
Now, I do not know, and it doesn't matter to me who said that. Everything that was said there is true, but to say it nicely and honestly, it doesn't make a connection. It doesn't make the connection to sort of the big idea. Let's see if we can maybe find one that does.
This means that there is a 140-degree angle with a y-coordinate that is 0.64 of the radius and an x-coordinate that is minus 0.77 of the radius. This could be seen as a 40, 50, 90 right triangle on the unit circle.
Okay, now getting closer. Do you feel like that there was some significant things that were said there? A y-coordinate, an x-coordinate. Okay, so again, it's getting close. It's better. This isn't just about trying to say what Miss Naylor wants you to say, but we're trying to make a connection.
This means that at 140 degrees the point, 0.6477, is the point on the unit circle.
Me too.
This means that at 140 degrees the point, 0.6477, is the point on the unit circle.
Now, I will say, because I'm getting even a little excited, that's really good. That is to the point, that makes the connection. If you're saying, what connection? Well, did you hear it? There's an angle that intersects the unit circle at a point. Okay, it doesn't matter what order you say it in, but those three things are what is happening. Can it be said different ways?
He's talking about a point on the unit circle in the second quadrant.
Okay, this kind of sounds similar. Now, to make that one super perfect, he's talking about a point. You should give the point. You should describe which one's x and which one's y. Okay, if the computer didn't read yours, it doesn't mean it's wrong. I'm just kind of scanning through these quickly. And it helps you to kind of see what people are saying. Let's listen to one more.
The angle of 140 degrees sin equals 0.64 on the unit circle, and the angle of 140 degrees is on the unit circle equals minus 0.77.
Okay, so there we're getting the idea that the angle is making those values on the unit circle. Of course, it would be great if you say which is which, which is X and which one is Y. If you're the kind of student that's like, okay, so what am I supposed to say? Again, I want to be clear, it's not you have to say what Miss Naylor is saying, but this kind of says the same thing you've heard a few times. Okay, it's sort of to the point. It says that we've got an angle, it intersects a unit circle, and we even give the point. Okay, now if you're like, where'd you get negative 0.77 or like 0.64? It's kind of weird. Calculator, and we'll do something with the calculator here in just a few moments. But the truth is, all the answers that you're getting, like all the answers on the homework, they can turn into decimals also. We don't turn them into decimals because that's more appropriate. But sometimes when you see the decimal, it helps you realize, oh, we're just talking about a point on the unit circle. Now, where are you at with the homework? Something that it's a lot of numbers, but can you pinpoint something? Is there something that you're not sure why you got it right or wrong? I would assume more wrong. Anything that you want to talk about? Are you sure with 62?
Oh, why do you sometimes on sine 56 like the -2 the square root over 2, and then on 62 like the one that's too graded? Why do sometimes you delete the bottom one, they cancel out, and sometimes they don't?
So why does maybe the square root in the bottom cancel out?
No, I mean on the top, I don't know.
But try to, because I want to answer it.
For 62, I got -3 square root over 3. So why did you get that, or did I put a 3 on the bottom?
I was kind of wondering, but I think the answer here is maybe it'd be better, and if you forgive me here, that I make sure that I have the sketch, that we're looking at the same sketch, which I think we are. But basically, this is a negative 240. Now, that's not necessarily easy, but we have to think about, okay, where is negative 240? The reason we have to draw the sketch again is just to make sure that the numbers weren't mixed up in the sketch, because if the number's mixed up in the sketch, then it's going to be mixed up in our answer. So, okay, there's negative 240. Now, it is negative, but the truth is the rest of this problem can kind of be thought of with just absolute angles. In other words, realizing that this is still going to be 60, so we have a 30, 60, 90. Don't think of this as a negative triangle or something with negative angles. 1 is across from 30. 2 is always the hypotenuse. Root 3 is across from 60. Of course, we've got a negative sign here. We might as well get that right. Just curious, were the numbers the same in the sketch? Okay, so that's what happened when you put your numbers into your definition. Something was flip-flopped. By the way, you'd have the right answer if the sketch you drew was the sketch. You did the right thing with the whole square root denominator thing. Anything else? Okay, can we show you something on the calculator? I guess I'm just is there anything still left over from the little warm-up or something else that, again, is on your mind? So we're going to do something on the calculator. Again, this is a little different because, well, we really haven't used the calculator. And when I say that, I mean use it for sine, cosine, and tangent. Maybe you used it to do the Pythagorean theorem. Sure, we get that. But what about doing trigonometry? Now, to use the calculator, there's a couple things we have to be aware of. And I'm trying to take care of a number of those things with just a few examples. But please, if you're like, I lost you, or what button did you push? And if you're like, I don't have a graphing calculator, it's okay. You don't have to have a graphing calculator. If you have a scientific calculator, much of what I'm going to show you is the same. You just have to find the menu. And so that's kind of what I want you to do. I want you to adapt to what you have. let's talk about this first because it's pretty important. No matter what calculator you have, there's a mode menu, and there's lots of different modes, but the one that we're looking for is the one that talks about if we're in radians or degrees. Radians or degrees. In some of your calculators, it'll be like rad and dig for radians and degrees. It's in like a mode. Just like when I give you a problem like number 62 that was in radians, you kind of have to like think, oh, that's a radian number. Or obviously if we give you a number in degrees, you kind of already realize that. So you got to tell the calculator what kind of numbers you're plugging in. Now you say, well, which is it going to be? It depends on the problem. You just need to be aware. You need to be aware of how the problem's given. So that's a little loud. Here's a problem which intentionally is supposed to kind of be fancy. I mean, we've got a cotangent, and we got this 2 pi over 3. There's a lot going on here. Okay, the first thing that's going on, though, is that it's in radians. So make sure your calculator's in radians. Now, the next thing that's going on is we're trying to do a cotangent. And I just kind of wanted to give you a chance if you want to try to play around on your calculator. If you're the type of student, you just kind of want to try it. If you're saying, yeah, but I don't really know how to do it, yeah, it could be. But maybe you want to try to do the cotangent of 2 pi over 3. Sometimes these answers pop out. That might be good, that might not be good. And if you didn't get any of those answers, again, let's talk about it. First of all, cotangent is the reciprocal of tangent. Okay, that language should kind of resonate from the day that I taught that to you, but I want you to realize right now, like literally, it is the reciprocal even on your calculator. Okay, not the little button above it. Now, the little button above tangent is called the inverse tangent. We haven't learned about that yet. We will. You'll understand the theory behind it. But what you want to realize right now is that that inverse tangent, the button above tangent, is not the reciprocal. So what's the reciprocal? Well, I got good news. It's literally the reciprocal. It's literally 1 over. Again, as you look at that, it literally is the reciprocal. It's 1 over tangent. And of course, the definition of reciprocals is to do just that, to write something as 1 over or to flip it. Okay, so to do the cotangent, I do 1 over the tangent, nice little 2 pi over 3, and out pops that sort of messy number. Okay, a lot of times we round it to like 2 decimal places, but I'm more concerned that you just know how to use your calculator to get that output. See if you're catching on. I'm purposely trying to give you a problem that makes you do a couple steps to think about the answer. This would be the cosecant of 5 pi over 3. The cosecant of 5 pi over 3. Okay, now you should have thought that cosecant is the reciprocal of sine. And honestly, as long as you realize that, you can do these, I'll call them the reciprocal functions, but they're kind of strange because they're not just on your calculator. You have to do a reciprocal. You have to do a 1 over. Okay, now, these numbers, we're not going to make you write an essay about what does that mean. Okay, because it's not real interesting. What does that mean? Well, it's r over y. Okay, it's r from a triangle, it's y from a triangle. You know, it is negative if we want to talk about that, but I'm not going to make you say, well, that's what this decimal means. I just want you to be able to find it. But let me give you one more again, just to kind of play around. You're trying to do the cotangent of pi over 2. Now, I'm sure that with the time you've spent with math and with a calculator that you've gotten an outcome like this. You know, you've gotten an error or a domain error, okay? Maybe it means the answer is undefined, or maybe not. Let's talk about the cotangent of pi over 2 without a calculator. Now, I hope this isn't a moment for panic, because pi over 2 is just a place. It's actually an angle, and we can all rotate to it. Once we rotate to pi over 2, we would be allowed to use the unit circle because we know the information at pi over 2. We know the x and the y. Okay, so when I write 0, 1, and maybe r equals 1, all of that is not a surprise. It's known. So what's cotangent? It's x over y. Wait a minute. X over y? 0 over 1? Well, last time I checked, 0 over 1 is 0. The calculator is spitting out no answer, undefined, error. So what's actually happening here? What's happening is, as all machines do, they're only doing what you tell it to do. You're telling it to do the tangent. And by the way, it was the right thing to tell it to do, but you're telling it to do the tangent. What's the tangent at pi over 2? That one is undefined. And then you're trying to tell it to do 1 over something that's undefined. And so it doesn't work. Okay, now, if you're like, oh, what do? You need to be aware. What you need to be aware of is anytime you're doing something that might involve a 0. Now, what might involve a 0? Only the angles that are in these multiples of 90, right? Those are the only spots where you can get a 0. So if you're doing one of those, you might want to just turn the calculator off. Okay, if you're doing one that's in a multiple of 90, you might just want to do it by hand. Okay, sometimes it'll work, sometimes it won't, because it depends on where the 0 is. Okay, so the right answer to this problem, just to kind of be clear, would be 0. It would be 0. One more. So, are you telling the calculator to think of the numbers differently? Did you change the mode to degree mode before you do the cosine of 160? Okay, before you do the sine of 160. After we do the sine also. Now, when these numbers spit out, kind of look like the little warm-up thing. You know, do you realize what these numbers are? Just the reason I'm doing this one is because sometimes an answer can be a sketch. And so just one more time, if you think about those 2 decimals, lots of sound effects today. If you think about those 2 decimals, it's that. Okay, now somebody says, can I draw that for my answer tomorrow? You can supplement your answer with a drawing. I want you to learn how to talk or write. So tomorrow when I say, hey, what's this mean? If drawing that sketch helps you to kind of put your thoughts together, draw it. Okay, but you still have to write with words the idea that there's a point that intersects the unit circle at 160 degrees. Okay, and of course it's that point. You'll get a chance to practice a little bit with your calculator. There's nothing else you need to know. I know it seems kind of weird. I just showed a few problems, but most of the test is, as I sometimes like to say, theory, the theory of trigonometry. Okay, now the review's a little different. For some reason, it's set up in like these boxes. I think there was a time when I used to have you pass these boxes around or something, but it's a little easier just to have them on a piece of paper. But yeah, do you realize like every one of these boxes is kind of like a different concept? And you want to be careful that you don't mix them up, although they are all connected. So maybe the boxes kind of help you to sort of keep each concept separate. There are some answers on the bottom, just answers. And then I also uploaded an answer key, like with the work. And so if you want to look at that answer key, however that helps you, know that on Google Classroom I put that there for you. I want to give you a little bit of time. So what's going to be helpful for you? Do you just need to work on some problems? Do you want to talk to